Well, I'm glad somebody said something. So it's entirely my fault. I was muted. So we're going to rewind and start again. That's funny because I was saying that today I'm sick, so there might be a little bit more stumbling around than usual, but I didn't think I would forget to unmute my mic. So this is a good start. All right, let's try again, but this time with the audio. So what I was saying is, I was saying that we are going to resume where we left out in the last session. So we did about half of the fake exam. Okay, we are going to take a quick look at what we've done. This is what I was doing without the audio, and then we are going to continue implementing. At the end of the session, Q&As, that's the priority. If you have any question, and you know, by the way, that you can interrupt anytime as well, so please do so, okay? But at the end of the session, definitively open floor Q&A if we have time, or we'll take a bite out of the second practice exercise that was also in the slides that I pointed out last time, the one on data store temperatures, okay? All right, so hopefully this time I'm not going to forget anything important anymore, and we're going to be able to go through it smoothly. So what we did last time, our main method, we had created a series of transform objects that contains a series of string transform objects. So string transform is a superclass. Reverse transform and letter transform are the subclasses. So together, those three classes represent transformation that we can apply on strings. And we pile them one after the other in that array list, pretty much. Series of transform is really just a glorified array list. As a matter of fact, it inherits from the class array list, okay? So next thing, we implemented this series of transforms. So we extended a release of string transform, provided a validate method that's just there to warn us in case, we reverse the string and then we reverse it again. Then it tells us, this is kind of weird. Reverse followed by another reverse, that's pretty much doing nothing. So it's a little bit more general than that. We check if there is an even number of such reversals. And if there is an even number, then we issue that little warning on the screen. But we don't stop execution. I mean, this is not a deal breaker. We can still go on, okay? But this is just to get like a warning pretty much to the user. And then we have the meat of this entire exercise, which is, once we have built a series of transform, how do we apply each of them in order to a string? Well, here's the key method, apply. So you give me an input string. I'm going to go and iterate through all of the string transform objects that I have in my array list, apply them one at a time on the string, and then at the end, I'm going to return the final result. And the same way that I have apply, I have undo, which is going to do exactly the opposite. It's going to, instead of going from the first to the last transform in the array list, is going to start with the last transform. So we're going to use index here, and it's going to work its way up to the first transform, index 0. And for each of the transform found in the array list, it is going to undo the changes. Okay, and then at the end, again, return the final result to me. Next on the menu, and this is where we stopped last time. So next on the menu, we have to implement string transform, and it's two subclasses. So the subclasses are going to be, again, reverse transform, extend string transform, and letter transform, which extends also string transform, okay? So letter transform and reverse transform are going to be very concrete, okay? They are going to be actual transformation that we can apply on a string. Now, the reason I'm pointing this out is because the superclass string transform is meant to just be there to factor in the code that would be redundant between letter transform and reverse transform. So it's going to be a little bit more abstract, okay? It's going to be a little bit more neutral. As a matter of fact, it's going to implement a transformation on a string that doesn't change anything. But that's not its main job, okay? Its main job is really to integrate all of the other mechanics that we are going to need in each and every one of our string transformation subclasses. So And for our case, for our example here, those mechanics have to do mostly with logging everything that's being done to a text file. So that's going to allow us to have a quick review of exceptions and input-output. All right, so let's take a look at what we are expected to do in string transform. To make this a little smaller. So first, a bunch of attributes. So I already explained pretty much the general idea. A bunch of attributes to declare. So these are always the easy points to grab. So I really recommend that you do those things first, when you start your final exam. So let's take a look at what we have here. A string input, which will allow us to store the string that will be passed as parameter to the method apply or undo. So when I ask to apply my entire chain of transformation, to a string, I save it inside an attribute. So private string input. Okay. Second one, a string result, which will do the same for the result of applying or undoing transformation. So this is my input output pretty much, okay? When you call the method, you set your input, then you are going to process your input, and then you are going to save the result in, there we go, an attribute result, okay? So the object string transform, when you call apply, like I said last time, doesn't return to you directly the result. It just updates an attribute internally and store the result. And then later, as we have seen already, we are going to have a get result method. And that get result method is going to be pretty much an accessor for this attribute and allow us to extract the result from actually the object. All right, so what's next? A string log file that will store the name of the file in which the string transform object should write some log information about what it does. All right, so again, private, bunch of strings so far. Okay, and what do you call it? Log file. All right, there we go. And the last one, a date stamp. So date, and we're going to call it time stamp. And here we are. Okay, so we have our basic structure here. Let me build to make sure that I have the proper import for date. Yes, I must have imported java util.star, if I remember correctly, so that will do the trick. So we have our 4 attributes, 2 points or something like that. Okay, let's move on to the next task. So the class will feature, and there was a question on Piazza about this, okay? The class will feature 2 constructors. So both constructors are defined, are described in this one set of instruction, but that's okay. I mean, it's like we just have one comment with 2 paragraphs, okay? And each paragraph describes one of the constructors. So I could have separated that, but it's really like the same information at the end of the day. So let's talk about the first one. A one-arg constructor, and it's going to take a string. So yep, this is this one, definitely. The string represents the name of the log file, and we use it to initialize the attribute log file. This constructor will also initialize the over string attribute, the empty string literal, the timestamp attribute to null. So empty string for everybody except the log file, and then a timestamp that is set to null. So we can definitely, we have like a one parameter here, so we can definitely go jump in and say this.log file equal log. Okay, this is the first step. Now input and result, yeah, we can set them to empty string. And then the timestamp, as per instruction, we are going to set it to the value null. Okay, so no timestamp recorded. I'm using the same logic that we've used with timestamps all semester long. Okay, nothing surprising here. We have a little problem with indentation here, so let me fix that. There we go. All right, and that's it for the one arg constructor. Then we have a no arg constructor. No arg constructor will appropriately chain to the above meaning the constructor that we just wrote, and specify a log file name as being the empty string literal. This will be used later in our code to denote that we do not want to write log information to a file, but instead display it on the console. So we are going to use exception in a kind of funny way here in this example. What we are going to do is we are going to say that if somebody specifies an actual log file, which if I scroll back up to the main, yes, we do have a log file here, an actual log file, txt, right? And we pass it to all of our objects. So if somebody gives me the name of a txt file, then I will log my information into that file. But if they give me empty string instead, then I'm going to assume they don't want me to log into any file, and I'm going to log information about what's going on the console itself. Okay, and to achieve that, we're going to use exception. If I cannot write to the file, then exception is raised, and I decide to write to the console instead. So that's going to be a kind of a slightly different take on what we can do with exceptions, but it's still the general goal of error handling, right? So how are we going to do all of this? Where is my, I lost my constructor here, so I'm going to have to add it. There we go. Public string transform, no arg constructor. And how do I achieve all of this? Any suggestion in chat? So this part here. Yep, exactly, River. So always look for an easy solution. Okay, that's the whole point of object-oriented programming, is that you have a lot of concept to understand and stuff like that. But at the end of the day, when you learn those techniques, those tools, those concepts, then you are able to write code that is a lot easier. So every time you see appropriately chain, something like that in the instruction, we are going to do constructor chaining. Constructor chaining allows you to have constructors that really do almost nothing and delegate most of the work to another constructor, and there's always somewhere a constructor that's going to actually do the work. Okay, so this is your, we could call it the main constructor pretty much. This is the one that's going to take care of initializing all those attributes. And that's it. That's all there is to it. So that's another two points that I really encourage you to get, like the attributes, the constructors. All of this should be relatively easy to get as far as points go. And then we have the apply method. So the apply method is going to, in this case, is going to not be that complicated, okay? But this is one of the important method, one of the method actually that we are going to override in the subclasses as well. So flavor text, okay? So I already explained what they do. The main thing to understand is, and this is why I took care to justify it here, is that this method is going to do something very silly. It's not going to actually apply or transform to a string. It's going to leave it identical. Think about, the identity matrix in algebra or stuff like that. You are going to leave things unchanged even. But what this flavor text is telling you as well is that this is just because we are in the superclass, and when we are in the subclass, we're going to override this apply and this undo method with much more useful stuff. Okay, so back to what we actually have to do. We have to call record log data. So that's a method. That's another method of the same class. I'm going to scroll down to show it to you real quick. There we go, record log data. So it has some work to do, and every time we apply, we are going to call record log data. And as you can see, the instruction here, they concern both the apply method and the undo method. So that means that the primary job of apply and undo is to always call record, if I can type it, that's better, log data, and we are going to pass whatever string we are working on to that method. Okay? So we're going to get to record log data, but just in a nutshell, record log data is a way for us to say somebody called apply with this string. So I have this string as input. This is what I'm going to generate as output. And if I need to, let's write this into the log file. Okay. So record log data, and then what do we have? What else do we have to do? Well, we are implementing a neutral transformation. So pretty much that means that the input is going to be left unchanged and is going to become my my outcome, my output. Okay. So how do I write this? Well, I say that the result is going to be assigned the value of the input, which is going to be assigned the value s. Okay. And once again, so this is the bare minimum framework. This is the most trivial transformation, the transformation that does nothing but still records some data about what's happening. And then, as you may guess by now, in the subclasses, what we are going to do is we are going to override, apply, and undo. We are going to make them do something more interesting, like reverse a string, change character from lowercase, uppercase, whatever transform we can think of. But we are going to chain also this overridden method to the version of the superclass here and here, so that automatically we have this record keeping behavior that is implemented by default without having to re-implement it by hand in each of the subclasses. All right. So next, one point, method get result. So again, some explanation, but I already went over that. This method will be called when we want to check the result of applying or undoing a transformation. Oh yeah, this is because undo returns void and apply return void. Okay, so I want you to pay attention here, like we are in the class string transform. So one string transform object, where is it? There we go. One string transform object, when you apply it to a string or when you undo it on a string, doesn't return anything. But if I scroll back up and I go to the undo and apply method for the series of transform objects, these return a result. Okay, I just want to point out the differences here. Okay, so that you don't get confused. I think it says to mark result as protected, Patricia. Let me check that. I might have missed it in my brush there. Yes, you are absolutely right. Please note that all the attributes will be private except for result attribute, which should be marked protected. So let's do that right now. Otherwise, when the subclasses are trying to manipulate protected, when the subclass are trying to manipulate result, yeah, we will get into trouble. So that would not go as a silent bug, which is always a plus, but that would still come back later to out. So protected string result. Thanks, Patricia. So now we can go back here, string transform the constructors, apply, undo, and what's next? The get result. So right now my get result returns nothing. According to the instruction, I'm going to have to do not too much in it. I'm going to have to return, of course, result. That's an accessor, okay, for the attribute result. But I'm going to have to do one more thing. The one more thing I have to do is call another method from this class named writeLogData. And the goal of this method, the flavor text explains that the goal of this method is to actually write a log, an entry log in the file. So write log data. And generally, there is a little bit of confusion about the difference between write log data and record log data. So record log data is pretty much let me store inside my attributes the information about what's going on. And write log data is let's use that information that I previously stored when I was applying and undoing to actually commit a log file entry to my log file. Okay, and we do that whenever somebody is trying to actually check the result, get the result out of our object. So all of this is, it sounds arbitrary probably, okay, but it's given to you through the instruction. You don't have to make it up. You don't have to invent it. It's given to you through the instruction. This is the way that the software was designed. This is how you are asked to actually implement it in Java. So very sweet and short method here, apply, undo. Let me mark them off my checklist here on the side. Get result, we are done as well. Let's move on to the next one. The next one, 3 points, a little bit more work to do. Now we're going to talk about record log data. And after that will be write log data. And we will be done with this class. So let's take a look at what we are asked to do for record log data. So again, flavor text, this method is called by apply and undo. Every time we apply or undo, we are going to record what's going on. It doesn't work. It doesn't work by writing log information anywhere, either on a file or on the screen, but instead it assigns values to our attribute. So we have an attribute input, an attribute result, an attribute timestamp. These are the ones that are going to be updated when we call record log data. So how are we going to update them? So this.input is going to be the string on which I am asked to work. This.result, I don't have a result yet. Okay, I haven't processed my transformation, so I'm going to say my result is the same as the input by default. Okay, and then timestamp. Timestamp is going to be actually a way for me to record at what time, what day and time this operation has been performed. So there we go, des.timestamp equal new date. And again, do I need des.input, des.result, des.timestamp? No, not here, because I don't have a parameter name here that is actually clashing. And as I say that, I realize that yes, this one is clashing, it's input. So des.input is necessary, and I should write here input instead of s. Now, if I add s here as name of parameter, as I was assuming for whatever reason that I had, then I would not even use the des notation. I would not have to use it, but I could if I wanted. All right. So record log data, that's it. We just update our attributes with pretty much information about what's going on and when it's happening. And this is actually the information that eventually will make its way to a log file. So talking of which, let's scroll back down. The next task, again, for 3 points that we have to do is write the method all the way at the bottom here, write log data, and let's see what we are asked to do. So this method is going to take the information stored in our attributes, so those attributes that we update with the previous method, and write down log information. But we have a choice, right? We can write down log information to the screen, or we can write down log information to a log file. How do we decide which one we do? Well, if the name of the log file is empty string, then we write to the console. If the name of the log file is anything but empty string, that means I was given a log file name, I'm going to write into that file. So the first thing that we are told is what format we are going to use to write into that file or on the console. And this takes like 1, 2, 3, 4, 5 lines to describe in plain English, but it's very easy. It's at the timestamp, and then a space, the input, an arrow, and then the result. So it should look like something like this, you know, at Monday 5th, blah, 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 2021. I'm just faking the date here, obviously. Then the string hello was transformed into the string OLLEH. That would be a reverse transform, okay, reverse string transform. So, okay, this is the format that we're going to use, whether we write to the file or we write to the screen. So let's start by actually formatting that string and get it ready to be displayed or written into a file. So I'm going to skip the rest of the instruction. I'm going to go here. There we go. And I'm going to say I want a string output. And that string output is going to be, and now I'm following blindly the instruction, right? The add symbol followed by the timestamp. I'm going to follow by a space, as I was asked to do, followed by the input, followed by an arrow, followed by the output. So output, in my case, is called result. So result, input, and timestamp are attributes, okay? So I'm building here a little string. Let's compile. I think that's been a while since I compiled, so let's get rid of typos. Yep, there are some typos here. Cannot find symbol des.timestamp, so it's probably a misspelling on my part. Let me go back here. Timestamp, yeah, timestamp with an uppercase S would be better, would be more consistent with what I've been using elsewhere. Compile again. I use timestamp with a lowercase s, very inconsistent. Sorry about that again. Control B. And finally, yes, we compile. Okay. So get rid of those typos. Don't wait too long to compile. Like you saw, it's very easy to introduce them. So I have this output string, local variable in my write log data method, ready to be returned to wherever I need to write it. And now let's talk about that. Let's talk about where I need to write it. Okay. So in order to make it so fine, the method will write this information into a file corresponding to the name provided in the log file. Okay, so that's the default behavior. What the text instruction is telling you is we want to open that file. Okay, we want to open that file, but if I open a file to write something in it with a print writer, the default behavior of the print writer is I'm going to create a new file. So if no file exists, that's okay. If a file already exists, it's going to either create an error or it's going to overwrite everything that was actually already in the file. So every time I call my write log method, I want to add something at the end of an existing file. So it's kind of a different scenario. I don't want to constantly rewrite the file because then I would have only the last log entry in my file, right? So I want to keep adding at the end of the file. The instruction tell you, well, with what we learned in the lecture, we cannot really do that, but here is a version of how to create a print writer that is going to allow you to say, I want this file to be opened in what we call append mode. Okay, so this is given to you because it was not covered in the lecture. Well, fair enough. All right, so I can take this code and I'm going to put it here. So I create an object of class print writer, just like we did in the lecture. Okay, that part didn't change. New print writer. But what I give to the print writer here is not directly the file name or the file object, right? What I give to it is actually the file object after it has been wrapped around inside a file writer object. Okay, so it's even more nested Russian doll. And where is this coming from? Well, the instruction tell you you are going to have to create a file object that represent that file that you are trying to write, right? So file equal new file, and I'm going to use the attribute log file. So the attribute log file contains a string that represents the name of the file. I wrap this around a file object. Then I pass this file object, I wrap it with around it a file writer object, which is a new stuff we haven't covered yet. And then I wrap around it a print writer. And then I have my print writer ready to use, just as we learned to use it in the lecture. So how did we learn to use it in the lecture? Print writer pw dot print ln, and my string is output. There we go. Okay. And then after that, pw dot close. Don't forget to close the file. Okay, so that's the logic, but if I try to compile this, it's probably going to yell at me because of some unfinished business with exceptions. Well, first it's going to tell me I cannot find the symbol log file. So again, that's probably just a quick typo there. Let me go back. Log file with an uppercase F, maybe. Private string log file. Yeah, you should be able to find it. Except that I use an uppercase F here. Yeah. So sorry about that. Again, there's apparently going to be a lot of that going on. Like I said at the beginning of the session, I've been sick since yesterday, and apparently that's affecting my coding a little bit. So, all right, we are going to try to work through that. So, okay, we have now things are spelled correctly, but this is what I was expecting. Now it's complaining about an unreported exception. So the error message is unreported exception, IO exception, must be caught or declared to be thrown. So these are the strategies, right? You catch an exception, strategy number one. You declare that you are going to throw the exception, strategy number two, or you do an hybrid catch and rethrow or something like that. These are the three strategies we learn to deal with when it comes to handling exception. So what it's telling us here is there is an exception that's going to be potentially thrown by the print writer. That exception is called an IO exception. That's the superclass actually of the IO exceptions. And it's going to have to be handled because it's a checked exception. Most of the exceptions that have to do with input-output are actually checked. So they force you, the compiler forces you, like you can see here, forces me to handle this kind of stuff. So how do we handle it? So quick review on exception handling. And this is where exception handling is very much like apply pretty much almost the same recipe. Once you learn to do it in a few scenarios, then you just apply. Jonathan, you got the same issue for log file. What was the change needed? The change needed was that I had uppercase F here. I keep going back and forth and mess up my camel case notation. So instead of log file, I mean, you can pick whichever you want actually. Log file with an uppercase F would make sense, but I spelled it like this in my attribute. So I'm going to go with this spelling for this time. Okay. So I was saying that the handling of exception, once you have done it a few times, it becomes really a routine. Okay, it's a pattern that you can apply rather straightforwardly. Cool, glad it worked. So you and I had the same bug. Sorry about that. I contaminate you guys with my bugs there. So it's going to become a pattern, and it's going to be, really straightforward to apply after a little bit. So I have all of my code here: file, print writer, println, close in a try block. So I know something can go wrong in that try block. I'm going to put a catch block. I was asked by the compiler to catch IO exception. Okay, so I'm going to say catch IO exception E, and I don't exactly know what to do right now with this. So I'm going to do system.out.println, and I'm going to say if there was any exception at all. So the most default thing you can do to handle an exception is display it on the screen. But here, I'm asked to do a little bit more in the instruction. The instruction tell me if you get pretty much a file exception. For example, you are trying to open an empty file name, on the disk. That's not going to work. Then what I want you to do is I want you to display on the console itself. Okay, I want you to display the line, the log entry that you were going to write into the file. So this is our log entry right here. Okay, the output variable contains that log entry. So I'm going to display that on the screen instead of writing it in the file. So if the file writing failed because my print writer told me, for example, hey, you're trying to open a file named empty string, I cannot do that, then we are going to display on the console instead. So it's just a slightly different spin to give you an idea of one more thing we can do with exception, okay? It's still error handling, but it's error handling in the sense of, well, if I cannot write to the file, I'll write to the console. And that works perfectly fine, okay? So hold on. Let me spare you here some unnecessary noise on the line. Sorry about that, but mute is a great feature sometimes. All right, so we have our little infrastructure in place here to handle exception around that file writing. Let's compile it, see if we have over exceptions to worry about or things like that. So I'm going to save, compile again. Okay, that works. So if I go back inside the instruction here, they pretty much already told me, to do what I already did, except that here it says make sure you handle both file not found exception and IO exception. Okay, so the IO exception comes from the file writer. The file not found exception, well, file not found exception will be triggered actually when we have the empty string. So why is it that I didn't have to do that here? Well, because file not found, sorry, exception is a subclass of IO exception. So this code here is perfectly functional. Now the requirement asks me to catch also another exception. So I'm going to take this catch block and I'm going to duplicate it. And in both cases, I'm going to do the same work, right? And the only thing I have to do here is to replace my name here by actually file not found exception. So I'm going to be lazy and I'm going to just go here and say file not found exception. So the only thing that I have to warn you about regarding this is the mistake that you could possibly make is to do things like this. And again, it will not be a big deal here because we do the same job in both catch blocks, okay? But generally, we don't do the exact same job in multiple catch blocks, so that would show up more easily in those scenarios. What I did here is that I started by catching a superclass, IO exception, and then I tried to catch a file not found exception. Okay, so the IO exception will always trigger in that case, and the compiler will let you know that and tell you by the time we reach this line, it will tell you file not found exception has already been caught. It has already been caught by actually this one, since file not found exception is a subclass of IO exception. So if you ever get that compiler error exception, for example, file not found exception has already been caught, and you are writing, several catch clauses like that, think about this example, okay? This is exactly what's wrong here. You need to put the most specific classes first, and then you put the general one. Question in the chat. I thought the file not found comes before IO exception since it's more specific. Absolutely. That's what I wrote originally, Jake. And then I switch it around just to show you what the compiler would do to you if you make the mistake. Okay. The idea being that all those compiler error message that I showed you last session and this session, I'm hoping to kind of like give you a immunization booster shot with respect to compilation error message right before the final, okay? So that we review together what kind of error can pop up, what kind of message they are going to show us, and what you have to do to fix them, okay? Because during the final, if you don't remember what a compiler error message means at all, with the stress of the final, it's going to kind of like snowball into probably a good 20 minutes trying to figure out what's happening, okay? And this is time that you need for implementing other features. All right, so let's try to compile again, make sure that I have it right this time. All right, we're back to the solution that actually works. And that's pretty much it for this method here. So again, comparing to everything else that we have done in the course, like polymorphism, dynamic binding, etc., all those concepts that were a little hard sometimes to wrap your head around, I hope that you all see that the file handling is actually considerably more straightforward. Okay, I didn't say it's trivial. I'm just saying it's more applicative, pragmatic, concrete, this kind of stuff. Okay. All right. And we are done with this class. So we just finished up our string, what is it? String transform class. So we have all the tools here to already inject in our series of transform object of class string transform. The only thing is that those objects are not going to do anything very exciting. They're just going to save into their attribute, that they were given an input string and that they spit out the same input string unchanged as a result of applying their transformation. Undoing is just as trivial because since we didn't do anything, undoing it is pretty easy as well. But now we're going to get into the actual string transformation. So to do that, as I mentioned before, we are going to subclass the class string transform. The string transform is my superclass, and I'm going to subclass it first with a class named reverse transform. As the name implies, reverse transform is going to apply a transformation to a string that simply takes it and reverse the order of all the characters. Okay? All right, so let's take a look at this class. So this class extends string transform. We already took care of that. It provides both a no-arg constructor and a one-arg constructor, allowing to specify the log file name as parameter. Well, our superclass did that already, right? So what we have here is a case of when you subclass another class, if that class needs for its constructor, for example, a log file name, well, it's a job of your subclass to provide a log file name to the superclass constructor. Okay, that becomes your responsibility. So how are you going to get that log file? Maybe you make it up, maybe you randomize it, I don't know. Or most likely what you do is you ask whoever creates an object of the subclass to also give to your constructor in the subclass a log file, just so that you can pass it to the superclass constructor. We have seen that pattern. There's specifically one good practice exercise that from the textbook that made you go through that pattern, like several times. So if you're a little fuzzy about that, make sure that you look back at your textbook practice exercise when we learned that technique, and maybe redo it. This would be not a waste of time, I think. So what do we have here? We already fixed that sooner because we had that compilation error, right? So we have a one-arg constructor already, and that one-arg constructor calls the superclass one-arg constructor and passes the name of the log file. Well, now what we need to add to that is a public reverse transform, and this time is going to be a no-arg constructor. So what's the deal with the no-arg constructor? If you do not give me any log file, I'm going to still chain with another constructor, but this time it's going to be a constructor inside this class. Okay, I'm not going to call the super constructor, and I'm going to chain to this constructor here that takes a string, and I'm just going to have to make up a name for that file. And the idea is, if you do not give me a file name, I'm going to set the file name to empty string. And now you know, because we already implemented that, right? You know that when it comes time to actually write the file on disk, if I try to write a file named empty string on disk, it's going to cause an exception. That exception is going to cause me to realize, well, I don't have a file name to write to, so I'm going to just write on the console. Okay? And we are done with the constructor, but let me go back, because there is something here that I neglected to mention. Let's go back to write log data just for 1 minute. Do you see a problem with this code? I did something stupid and I was going to fix it, and then I forgot to fix it, which is a good impetus, to not do stupid things when you program to start off with. But does anything bother you at all in this code? A one enclosed. No, you don't need to put any parameter. But yes, the reverse chat message. Close the file is the exception are caught. Okay, that's why we talked about the finally block, and that's why we talked about that new syntax, the try catch syntax that accepts parentheses. Okay, because the way that you write it here, like this is a natural way to write it. Okay, create the file object, create the print writer object, use the print writer to send some data into the file, close the file. I'm done. That's so natural, right? But the problem is that if this succeeds, okay, if I can create the file object, which most of the time, yeah, you can, then you try to create your print writer. You get an exception. The deal is we jump over this line and this line. We skip everything else in the try block. so that we can go and catch that exception. And we try to catch it here. And if that doesn't work, we try to catch it here, right? That's how exception works. So that thing where if this statement fails, we skip over the rest of the try block means that we skip over writing data to the file, which makes sense. I'm not going to write data into a file if the file is not able to be opened, right? But then I skip also pw.close, and that's a lot more annoying. That's a lot more annoying because, like I told you, every time you open a file, you have to make sure that you close it. That can cause some nasty little bugs when the output buffer is not properly flushed to the disk. So this is not where you need to put your pw.close. Definitely not. Okay. So where do you need to put your pw.close? Well, one of the possibilities would be to say, here comes a finally block, and I'm going to put my pw.close right here. So this would work. Why? Because if an exception occurs here, yes, we are going to skip everything that's left in the try block, which is a pw.println output statement. But then we are going to try to catch this exception. If we fail, we are going to try to catch this exception. Let's say that we succeed. We are going to execute this code. And then, no matter what, we execute finally. So if an exception occurs and I catch it in one of my catch block, I run finally. If no exception occurs, well, then I'm going to execute pw.println output, and then I run finally again. What else is possible? What is a third scenario that could happen? An exception occurs, but it doesn't match this catch block. It doesn't match this catch block. So what's going to happen is that the exception is going to, we use the term bubble up, right? It's going to be rethrown by your method. But guess what? Finally, it's still going to get executed first. So all possibilities are covered, okay? That's actually the correct way to close your file. Finally block, or if you prefer, I'm going to comment this out for now. w.close, I could also do something such as try, open parentheses. I'm going to put it in parallel, actually. I'm going to take this, but I don't have to comment like several lines, etc. And I'm going to put the over version right after it. The over version would be try, parentheses syntax, okay? These are my resources. So I'm going to create a file, create a print writer. So I declare the variables and I initialize them, okay? Then in my try block, the only thing that I have left is I'm going to try to write stuff, okay? And if an exception is raised here or here, it's going to be caught by one of my catch block. And finally, and the finally I don't even need anymore because automatically with this syntax, when I get out of the try catch block structure, I'm going to close all of my resources. So I'm going to close, for example, my print writer. Okay. The print writer is really the resource that has to be closed. I think the file we don't really need to worry about, so we're going to put it outside. Okay. So that would be another way, and I'm going to comment it like that, alternative way of doing it. I'm going to put all that in the comment. So when I upload the file to Canvas, you'll have both syntaxes, okay? But right now, let's go with one of the two. It doesn't matter which one. Let's just make sure that it's properly typed. So cannot find symbol pw.close. Yeah, it's because I declare my print writer inside the try block. So we're going to fix that. We're going to say print writer right here, print writer pw is declared, and then pw equal new print writer. Do I need to worry about the file? I'm not going to use the file anymore, so I think we should be okay. Let's try. Compile. Oh, you have the exact same problem, Stephen. Variable pw might not have been initialized. So what I'm doing right now is what you need to also do, Stephen, to fix the problem, okay? So just as a recap, the problem was that pw was declared inside the scope of those curly braces, so inside that block, which means when you get out of the block, it doesn't exist anymore. Okay, that's a problem. So I fixed that by declaring PW before, so that it's still accessible in the finally block. Okay, but now it's telling me your PW is not initialized. Okay, I'm going to initialize it to no, so that there's no problem there. And then compile again, and now it's compiling. All right. Okay. What else? So we did a little bit of a flashback here. We went back because I forgot to explain something. So we went back to write log data. We discussed about where we need to put the clause. That doesn't work, Jake. So what are you getting? Let's take a minute here to make sure everybody has code that works. Are you getting a compilation error or? So it says that PW is already initialized. So that means that PW was initialized somewhere else. Let me show you. You have to go through the code line per line here for write log data. Double check that you have exactly what I have here. Okay. And let's make sure that print writer is not defined twice. Like, for example, if you have still print writer here, yeah, it's going to complain that it's defined twice. So you need to remove print writer from line 285. There we go. Bingo. Awesome. Easy enough. All right. So let me make sure that I didn't break anything. Build again. So we went back a little. We commented on what is the best position for us to actually close our file. Now let's move on. Let's go back to the next class, reverse transform. We were in the middle of writing actually the constructors for reverse transform. Now we have to deal with apply, undo, and we'll be done. So how do we apply this transformation? So the first thing that we said is we are going to override the apply method. Well, here we are. We are indeed overriding the apply method that we inherited. But another thing that I said is the whole point of having a superclass that has an apply method is that that apply method was going to take care of all the bookkeeping for us. Okay, it was going to take care of recording the data that has to be eventually returned to the file or to the console. So as I override it, I'm going to call the version from the superclass. Okay, which class are we in? We are in the class reverse transform, which is a subclass of string transform. Okay, so I'm going to try to keep it on the screen. I'm going to call the superclass version of apply so that it's actually, doing all of its bookkeeping, and it's applying also the stupid transform that is doing nothing, right? It's not touching the string that I was given as input. So that one is in the next class, Jonathan. We are in reverse transform, and reverse transform is before letter transform. The one you are thinking about is letter transform. Okay, it has that private int shift attribute in it. So I'm passing my string to the superclass. It doesn't do much with it. It doesn't modify the string. No problem. Anytime you guys have like a different behavior on your computer, just say something. Okay, if we can fix it real quick like that, we'll do. If we have to share screen, we'll do as well. Okay, this is a review session. I want everybody to be on the same page up to the very end. All right. So we pass that string. It does its bookkeeping. It says the input is a string S, the output is still the string S because I'm not modifying anything. And now we return here. So now we are going to modify something. So we need to reverse the string. So there are different ways to do that. Okay, I could be lazy and actually call the reverse method from the string class, but let's just write some code since this is a review. Okay, that's not going to hurt us. I'm going to say, you know what? I need a string result. Actually, I have a string result. This is my attribute. Okay, so I'm going to set my attribute result to the empty string, and I'm going to iterate over the string you gave me, start at the end, and add each character to the result, concatenate them one after the other. So starting at the end of the input string, going towards the beginning, yes, I'm going to insert all the character one after the other in reverse order. So how do I do this? For loop, and then inside the for loop, an index. So my string is s, so s dot length -1, I greater or equal to 0. And then I minus minus. So this is just for me to access every character inside the string s. So I'm going to be able, again, a quick review on string manipulation method. To access the character at index I, you write s dot char at and the index between parentheses. So what am I going to do with this character? Well, I'm simply going to concatenate it at the end of my result string attribute. Okay, so go and check all the character in reverse order, insert them all one after the other inside the string result. Okay, that ought to do the trick. Okay, that's one of the possible way to reverse. Again, like if I wanted to be lazy, but I would call that the good kind of lazy, I would have just used the reverse method from the string class. Okay, but let's say that the instruction, even though they don't do it now, let's say that the instruction told me, no, 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 you have to write your own for loop. Well, there it is. I have my own for loop doing the work from scratch. And that's how I apply the transform. How am I going to undo this transform? If you give me a string that has already been reversed, how am I going to unreverse it? Well, I could do exactly the same thing, right? I could go here, and I could say, here we are, cut and paste. Here we go. To unreverse a string, I just have to reverse it again. So the same code that I used to reverse in apply, I use it again to reverse again in undo. Okay, so that's one way to go about it. It's not too bad, actually. It's just like, well, you know what I'm going to say, right? There's redundancy in code, so we can do maybe a little better than that. What can we do better? Well, first, we should not call super.apply. That's the problem with cut and paste oriented programming, is that and that's exactly what River caught on as well, is that you tend to jump to conclusion and then you leave like little things there that do not work out. So in the undo method, I should chain with the undo method from the superclass. So that's the first thing that I can do a little better, and that's a big deal. It would not change the behavior of our code in this example, but still, it's a mistake. Okay, it's one of those silent bugs that 5 release down the stream is going to manifest itself, and everybody's going to wonder where that's coming from. So, what else? Well, that code here is redundant. Again, not a big deal, but if I want to actually do the same thing that I'm doing here, I could call apply. Well, it's not that easy. So let's say that for a second, I go with this. I say, all right, let me comment out all of this. And I'm commenting it because we're going to put it back, okay? So I try to comment this out, and I'm going to call apply s. I do this. It's going to work in this case because of what I do in apply and undo in my super class, okay? But there is a little problem with it. So the good point about it is that my code becomes less redundant. If I'm going to reverse again, then yeah, sure, I'm definitely like recalling code that already exists here. But when I call apply, I get more than I bargained for, because I not only get the code that reverses a string to be applied, but I get also super.apply s. So in terms of the bookkeeping, this is going, when I do an undo, it's going to call the superclass undo method to do its own bookkeeping. Then it's going to call the superclass apply method to do the bookkeeping that corresponds to applying. In our case, we are lucky. This is the same thing, so it's not a big deal. But still, I mean, this is bad design, right? And then it's going to reverse the string. So how could I do that differently? Well, the easiest way would be the cut and paste, like I had here, okay? Short of that, if I don't want to do that cut and paste really, then I could say private string reverse string s. So I'm adding a method even though I was not asked to add this method, and I'm going to use this loop here in there. So there's going to be a loop that say for int I equal s dot length minus 1, blah, blah, blah. And so instead of result here, I'm going to probably use a local variable tmp. So string tmp equal empty string. And at the end, return. So what did I do? I factored out code that repeats itself. Okay. And here, since my goal is to set the result attribute, I'm going to call result equal reverse s. All right. And here, instead of calling apply s, then I can simply do result equal reverse s. So I'm nitpicking a little bit here, but I'm trying to reinforce the value of avoiding code redundancy and how sometimes cut and paste oriented programming, can skip details, and as sometimes you think you have a good solution, for example, calling apply here, but it turns out to have some little side effect that even though they don't manifest themselves. So you have to be really careful, okay? When you refactor, you have to be very careful that you do not change actually the behavior or the structure of your code in any way that might actually come back and bite you in the rear later on, okay? Here, I achieved that by simply saying that apply and undo, they both call their superclass equivalent, to do the superclass counterpart to do some bookkeeping. And then what they do is they reverse the string and they store that in the result attribute. The part that was really common to the two method was the reverse technique, okay? So should I write my own reverse or should I use s.reverse here? Yeah, I should use s.reverse, okay? But again, just for the sake of writing code during the practice, having our own loop is not that bad of a deal. All right, and we are done with this class reverse transform. Now we're going to get to letter transform, which is the one that you were already on sooner, the one that has that private int shift. So what are we talking about here? We're talking about doing another transformation. This other transformation is going to actually take each letter one after the other and use the fact that letters are stored internally in what is called an ASCII table. So they each have an index in a big giant array, pretty much. So let's say the letter A, for example, is at index 64. So if I was to add 1 to the letter A, Java allows me to do that. And what it does, it adds 1 to the index that represents the letter A. So now we're at 65. And guess what? 65 represents the letter B. So this shift attribute here is going to be how I'm configuring that letter transform. And it means that I'm going to add to every letter the same value. Like I'm going to shift all the letter forward by 1, or if I put -1 in shift, I'm going to shift them backward by 1. So A would become a B, a D would become a E, a F would become a G, and so on and so forth, okay, with a value of 1 for the shift. If I have a shift of -1, then the B would become an A, and stuff like that. So it's a very easy way for me to change out pretty much the letter in a string. I don't change the number of letters in the string. I just go one by one and change each letter individually. So that's the overall goal. So now let's look at the instruction and the detail of what we have to do. It has to provide both a no-arg constructor and a to-arg constructor that allow us to specify the log file name as well as the shift value. So we have a to-arg constructor here to set the shift value if we want. Implement them using proper constructor chaining. The no-arg constructor will specify a character shift of 1. So let's see what we have. We already add a constructor, but we use the one-arg constructor, okay, because this is just what we needed to get it to compile. So the instruction do not ask us to have a one arg constructor. So you know what? We're going to modify this. I'm going to say int shift and a string log, okay. So I have a 2R constructor now. It's still calling the superclass constructor, just passing the log, because the superclass constructor doesn't know anything about the shift value, okay? And then it's going to set the attribute shift to the value that you pass for shift. But doing that is going to break some code, okay? It's going to break some code because my code was assuming that I had a 1-arg constructor for this class. So if I try to compile this, it's going to complain. It's going to complain. It's going to tell me here, wait a minute, what are you doing here? You are trying to create an object of class later transform using a 1-arg constructor. I don't have that. All right, so be it. Let me put a value for shift. Now I compile, and it's working. Okay. So we have a value for shift. I have to scroll down all the way. That's going to be easier to go just to the end of the file. There we go. And now I need a no arg constructor. So let's go for it. Public letter transform no arg constructor. Again, constructor training. What am I going to do? Well, if you do not give me any details, I'm going to chain with my 2arg constructor. I'm going to assume that we have a shift value of 1. This is what the instruction asks me to do. And I'm going to assume that the file name is going to be empty. If you don't give me any information, these are the default that I want to go with. Okay, so that's pretty much it for the constructor for later transform. It would be nice actually to have. I mean, this is not asked in the instruction, so we're not going to push forward. Okay, but it would be nice also to have a 1-arg constructor that takes only the log file name and a 1-arg constructor that takes only the shift. Okay, that would give us a set of 4 constructors total that are going to accommodate any partial information that somebody wants to give me when they create the object of class later transform. As a matter of fact, you know what? Let's do it. It's just going to take like 2 minutes. Public later transform. And let's say that you give me only the shift value. Little bit of a typo there. If you give me only the shift value, then I'm going to pass this shift value to whatever constructor I'm tuning with, and I'm going to assume that you don't want file name. Okay, and then the last possibility is public letter transform. Let's say that you give me only the log file name, so log. If you give me only the log file name, then I'm going to make up a shift value of 1 and pass the log file name. So again, this was not required per instruction, but I think it's a neat little example of how you can equip your classes with a bunch of constructors without having to redo the work of the constructor like a bunch of times, because we are all chaining to the 2-arg constructor at the end of the day, okay? But this allows you to implement default behavior, default value for the parameter, and this allows people to create object of your class when they don't have the whole information, or they don't care about the whole information. They just want, to tell you the log file to use or the shift value to use. Okay. All right. What else? So this, we did more than what was required for the constructor. Let's make sure that I didn't introduce a bunch of typos there. All right. Now apply, undo, and we are going to be done. So apply and undo. So again, here there is a little bit of we are going to use a trick that we see in COP2513, okay, to increment by 1 character, something like that. That's not a big deal. That's not relevant. I'm going to go fast over it. It's just for us to have something that we can do, okay? But this is not really the stuff you have to worry about for the final exam. If I have to have you do a trick like that, and I'm not sure everybody covered it in COP2512, I will make sure to describe it in the instruction. So you got a compilation error there. Constructor later transform in class later transform cannot be applied given type. So let's go back to, let's make sure that your two argument constructor is okay first. Okay. Then you call superlog, only one parameter. If that one is okay, then what would happen, what would possibly generate that error is one of those calls here is referring to something different than the toArg constructor. And remember that your toArg constructor takes the int first and the string second. So you have to make sure that you always specify the int first, the string second, the int first, the string second. So this has to be an int. This has to be a string, okay? And the int first, string second. So in order of debugging, make sure you have the same thing for the toArg constructor. Then check out this one, and then look at those two. And let me know if you spot a difference. And if you spot a difference, then there we go. We fixed it. If not, that means it's in the main. Okay? So in the main, maybe you don't have yet the for constructor, and you're trying to create to call a one-arg constructor, and it's not working. Failing all that, share your screen. Share your screen, and I'll take a look. Okay. And I'm going to make sure that you think it's in the main. Okay. So let me scroll up. Let's save the screen sharing for the last option. Okay. Let me scroll back up. This is what I changed in the main here. When I do a letter transform, I ask it, to do 1, comma, and the name of the file, which is log. And if that doesn't show a difference that helps you fix the bug, just made you a presenter. So feel free to go ahead and share your screen, and we'll take a look together. Any luck? All right, I see a screen sharing coming up.
Can you hear me?
Yep, I can hear you too.
Okay. So I went back to the main and fixed that one issue, but then I still get this error.
All right, let me take a look real quick. So
it could be a rookie mistake. I must say that.
That's okay. I mean, it's always an easy mistake when we catch it, right? Constructor is already defined in class letter transform. So hold on, it's complaining about the int string one being defined twice. Ah, I see it. The first one on line 369 is a no arg constructor. So remove those int shift and string log. So that prevents it from having actually this definition go through. Let's try to compile again. That should get rid at least of the first error, and if we are lucky, of both errors. Awesome.
This is why we don't copy and paste.
And this is why I keep doing it, and I keep showing to the student why you don't cut and paste, right? Every time I try to cut and paste, there's something like that happens to me too, so don't feel bad. But I did tell you guys for both semesters, those of you who had me for both semesters, that by the time you're done learning programming, you're going to be really good at Where's Waldo, because you're going to be able to catch little details like that. And that's actually one of the difficulty when we are debugging. Sometimes we can read the same code 5 times and we still don't see what's wrong. So it helps to have another set of eyes, take a look. All right. So let's go back to our letter transform class. I'm scrolling super fast to the end. We're about to start apply and undo. So what are we going to do in apply? So we are going to iterate over every character, and we are going to change each character by shifting it, by the value of shift. So first thing first, I need to do my bookkeeping. So super.apply s. And here it's going to be super.undo. Okay, so I chain to the version that I'm overriding. And then after that, After that, well, results equal empty string, okay, for int I equal 0. So this time I'm going to go over each character one by one from the start to the end, not in reverse order or anything like that. So I use my index like this, s dot length plus. And then inside the loop, so this is where there's this little trick that, this is not the most important thing in this course, definitely. So I want to concatenate to result. I want to concatenate the result of taking the character at index I inside of S, adding to it the value of the attribute shift, and then this is where some of you might not be comfortable, okay? And then I'm reconverting that because the result is going to be a number. I'm reconverting that into a character, and there we go. That's it, okay? So this allows me to actually change, to apply the shift pretty much to the shift value to every character in my string and create a new string and store that new string in the attribute result, okay? What about the undo? The undo it's the same logic, but instead of adding the shift value, you want to subtract the shift value, okay? So it's going to look really similar. I'm going to just cut and paste. And again, cut and paste, right? Cut and paste oriented programming, little bit of redundancies. The only thing that changed between those two pieces of code is that sign. Yes, I could do better than that, okay? I could do what I did with reverse. I'm going to leave it as an exercise because of time. I want to have some time to at least open the floor for question and get into the data store maybe. Do we change the input to S? Yeah, I keep using S. Sorry about that. Yes, we change input to S. I was using S here, and I just got carried over right here. So super.undo S, result S.length. I'm just double checking that it's consistent this time. Yeah, it is. All right. So, Jack, no problem. We are going to record the rest. Okay, so you can catch up with just that last part of the video. But yeah, we are reaching the end of the regular, we are past the end of the regular time for the class, but we are going to keep going for another about 45 minutes to just have more time for review. That's pretty much it here. Okay, we have everything. So the one thing that I did, and I did it for the sake of time, but I'm not convinced this was the best move ever in my career. What I did here for this review, I focused on explaining what I was doing, modifying the code, explaining to you what the code was going to do, and etc. So it's kind of like a little less live coding than the usual live coding we do, because the usual live coding we do, I'm testing all the time. I'm not only compiling all the time, but testing all the time. So here we are in a situation where, well, I have a little typo to fix here first, but we are in a situation where we saved pretty much our testing for the end. So this is generally a bad idea. For the final exam, I just want to put that out there. Do what we have been doing all semester long, okay? Compile, write a little bit of code, compile, test it, compile, test it, compile, test it, okay? I just wanted to make sure here we would have time to go to the end and me showing you pretty much how the code function and ticks and explain all the method. Now we are going to try to run it, so we are going to maybe bump into some bugs while we are going to switch to a debugging practice then. Not ideal. I don't like debugging if I have a choice. I prefer to write code incrementally and not have to deal with as many bugs. But let's face the fact, during the exam, some of you are going to end up with bugs. So if we have to go through debugging, well, that's going to be kind of a reminder of how to use the debugger and stuff like that. So all in all, it's not a good way to do it if you do it for a job. It's not a bad way to practice if you are preparing just for a final, okay? All right, so let's back off from runtime error first. Cannot find symbol S. So did I use input again somewhere? Line 405. Des.shift, s.char at. I'm missing something. Oh, char at is spelled wrong. chart at, yes. And by the magic of cut and paste programming, we have the same bug, cut and paste twice. Awesome. If I really wanted to show you how not to do it with cut and paste programming, I think I did a good job today. All right, there we go. So char at, I should have compiled after the end of this and then move on to the next one. Control B, let's see. All right, so it's compiling. So now let's go back and see what we have in the main. What we have in the main is creates a transform, add a bunch of transforms. So there's a lot of stuff to compile. Okay, but let's see first if we can add all of those transforms. Okay, that's going to be the steps I'm going to fix myself. I want to see if I can add all of those transforms to my object, and then the validate should tell me that I have actually an even number of reverse. I think, right? Reverse. No, I have an odd number of reverse, so I can fix that. I can change the test here to have an even number and trigger that validate warning. That's another thing that I need to test. And then finally, I need to check that that I get this data right here in a text file. So let's see here. Where am I? Am I in the right folder here? I'm not in the right folder. I'm going to go look for, there we go. This is a folder where I have my code. So this is a folder, this is a current working directory, right? So this folder where the text file will be created if it works. So let's build again and let's give it a spin. All right, so let's see what we have here. So we have undoing series of transform on blah, 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 blah. So first good news is that it looks like we created all of our transforms correctly. Okay, it looks like we added them correctly inside the series of transform object. So then the last thing we do is pass that weird string that has been encoded, and it decodes into something that looks readable. So that means that the code is actually operational. And it says, do you remember when exams had squirrels in them? And I do apologize, this is completely out of context. But I did have a semester, like I said, this is an exam from a previous semester that I modified slightly to make it better for practice. And we had a year where we had a lot of exams on squirrels. You remember, Eric? Okay. And this is what it's referring to. Anyway, so all right, it looks like it's working. What about the file? What about the part that writes actually into a file? Well, there is a file that got created here, log default txt. So it has the right name. And if I open it, hey Sam, if I open it, I'm getting something that looks actually correct. Let's double check together, right? Um, so we have the timestamp. So the timestamp is not going to change a lot because all of this executes in like literally like, I don't know, 10 milliseconds, maybe something like that. So the date is not going to change, of course, but this is the input string. This is what it gets transformed into after the first transformation is applied, or unapplied, I should say, undone. And then we take that string here, is the input of the next transformation, and we get this, and then we get this, and then we are here, we get something that starts looking like a sentence, and then we reverse it one final time, and here we are, we have our sentence reverse. Okay, so yeah, it works. I was expecting at least one or two little bugs on the fly. Don't use that as a model for what we have been doing all semester during COP2512 and COP2513 again is really what I want you to do also during the final, which is write a little bit of code, compile it. When it compiles, test it. When it tests, then move on to the next code. Okay, it's really risky to write the code. It's okay because I knew already where the program was going. If I was writing a piece of code that I've never wrote before, then I would not be so bold. I would not be so careless. Okay, I would actually apply the same method that I teach you because that's the only way to not have to deal with a bunch of bugs at the end. All right, but that being said, this is it for this fake exam. So I will upload that file to Canvas so that you will have COP2513 final exam review AM, which is what we did last time, and then AM2, which is going to be the second half that we did today. And we still have at least half an hour, 33 minutes, something like that. So we do have time for doing a bunch of stuff. So first thing I would like to say is, any question, let's open the floor, okay? Anything that you can think of about this fake exam, about the logistic of the final. I see that Kayla has a question about the logistic, I think. Ask them now. Let's take care of all those questions, and when we are done, we'll move on to the data store temperature. I'll try to get you started with it. So on Tuesday, you told us to bring our student ID for the exam on Sunday. Right now, I don't know where it is, so can I bring another form of identification like my driver license? Absolutely. Yes, that will work. No problem. Don't worry. Okay. But try to find it, I guess, is a silly advice to give you, because when you lose something, it's hard to find. But try to get it replaced, right? Just in case you need it for another final exam in another semester. Okay. But driver license is perfectly fine for me. No problem. All right. Anything else that you can think of? Question about the fake exam, the logistic, or even, question about things like, I have problem with a release. My point here is that before I go on with what I have planned to do, which is the data store, okay, I want to make sure that if you guys have different needs, we can address those different needs first, okay? And while I leave the floor open for question, I'm going to go slowly so that there's time for question, slowly open the PowerPoint so that we can take a look together, if there are no questions, to the second review exercise. All right, looks like we have no question. If you think of anything, please feel free to chime in, okay? So in the absence of question, I'm going to go with the initially planned stuff, which was talk a little bit more about file I/O and exceptions, because there was really limited exception in that fake exam. But that's kind of realistic. When you do exception just for the sake of doing file I/Os, then yes, you're going to get like a basic pattern like this. Question in the chat. So you won't be proctoring either. It will be a different instructor. No. I'll be there Sunday. Sunday, all of us, all the TAs and I are going to be there with you guys, and I'm going to be proctoring in class. And then, just in case I misunderstood your question, there's going to be also honor lock working in the background, just to check, your internet connection and stuff like that. Like, so for example, if somebody tries to Google something, then HonorLock is going to keep tabs on that, because it would be really difficult for us to to monitor like 130 students, I think, in a room, and make sure that nobody is using their laptop, in a non-allowed way, pretty much. Okay. So yeah, it's going to be me and the TAs all together Sunday, and we're going to get that final done. And you guys are going to do your best, and I hope that you all pass. All right. So will you be posting this recording on Panopto Cloud? So no, not Panopto Cloud, because I use Blackboard Collaborate Ultra to record, Stephen. So what I do is that I download the video, I upload it to YouTube, and I just put a link to YouTube. Instead of putting a link to Panopto inside the module, I put a link to the YouTube video, but it's the same, okay? It should be the same quality. If there are problems, just let me know, okay? So it's not Panopto Cloud, but it's you're going to still get the recordings. Question about adding reverse transform objects. We needed to add a total of 3. Can't we just use the same object and add it 3 times? Yes, that's a very good one, Patricia, actually. Instead of creating all those objects of type reverse transform, and they are all doing the same job, absolutely, I could use the same reference to one object, and that object would be inserted at 3 different locations in the series of transform. So yeah, very good idea, actually. Question from Robert. My laptop dies fast for the final. Should I find a different computer, or will an extension cord be best? So here's the deal, okay? Officially, it's even worse this year because they located us in a new room, okay? A room that I've never used for final exam. So I don't know yet what to expect in terms of layout, in terms of number of plugs and stuff like that. But here's what I try to do every semester. I tell you there are no plugs so that you prepare for the worst, okay? Preparing for the worst means, for example, if you can borrow easily another laptop, then do it. Okay, get a machine that's going to last you 2 hours, no problem. Make sure that your software is installed on it. Try to eliminate any possible source of problem. Now, the day of the final, if I have like 2 or 3 students that I need a plug, we can most likely find a way to make that work. I say most likely because again, I don't know the layout of the room. Okay, I don't have a problem with moving the students who have problems with the battery near a plug, connecting an extension cord, and so on and so forth. Okay, the problem is if the day of the final, I have like 15 students in front of me that say, well, I assume that we could work out something, and we look at each other and there are 3 plugs in the room, then we are all in serious trouble. Okay, so that's what I want to avoid. So if you have any way to pretty much bulletproof, the situation for Sunday, please do so. And then I'll do the best I can, there like to address any last minute emergency. Okay. I had somebody in a previous year that literally opened up their laptop during the final exam, and the laptop died right there. Um, there's not much you can do, right? So we try to work out something, don't worry. But the deal is we try to be prepared and avoid as much as possible problems. And then when the problems are unavoidable, we deal with them. No, that's a very good question, River. But if you scheduled it with SAS, what's going to happen is that they are going to have a room, and they are going to have a proctor in that room. So that's not going to be me this time, but they're going to have a proctor from the testing service team probably that's going to proctor you while you take the exam in a different room at a different time. Okay, but it still has to be on campus. And I do apologize for that because I was really thinking that this semester we would be able to have like actually online final exam again. But I did check that early on with my department chair, and the answer was a clear no. Okay, everybody needs to come to campus for the final exam, so I cannot make any exception. Do you expect any curving on the final? I hope not, Zachary. I really hope not. Okay, we designed the final exam. I think 2 out of 3 of the TAs went through it, took it, so we make sure that they can complete it, in a fraction of the time that you guys have. So, for example, an exam that takes 2 hours for the student, we expect a TA to be able to complete it in about half an hour maximum, 20 minutes, something like that. So that's how we design the exams so that they are not too long. Um, it happens, it happens that despite the review and stuff like that, sometimes an exam is just too difficult or it's just too long. So if that happens, this is when I generally see it with a grade distribution, and then I apply a curving. But this is the only time where I consider applying a curving. Okay, we don't design the exam from the get-go to be too long or too difficult. We try to, to be reasonable there, to have something that's challenging but not overwhelming. So normally we don't need curving. But if the grade distribution shows it was a catastrophe for whatever reason, then definitely, yeah, we keep it fair. All right. So that's a lot of question about the logistic. Very good. Uh, I would say get them out of your system, right? Anything that you can think of, ask now. If not, then ask on Piazza anytime, okay? Is the final finalized? As seen in Canvas, it says 22 points. Is that all? Yes, that's actually what we have right now, and I don't expect it to change between now and the final, okay? Don't worry too much about the number of points. That doesn't mean necessarily it's short or it's long or etc. Because every time we grade something on even just 1 point, we do partial credit, okay? We try to avoid binary grading, where it's either you get it right and you get 1 point, or you get it wrong and you get 0 point. Even if you got it partially right, then every single point that is going to be assigned to you during the grading of the final exam will be also open for partial credit. Okay, so whether we have 22 points or 44 doesn't make a difference from that perspective. Does that make sense? So what we went over in the final review is just about what to expect. So like I said, it's actually more than what to expect, okay? Um, I hate doing a review where everything is easy, trivial, and then the final exam is 10 times harder. If I have a choice, I prefer to do the opposite around, meaning that the review is actually harder, more open for interpretation, maybe a little bit more ambiguous, etc. We work through it together, and then the final should be hopefully, finger crossed, straightforward. Okay. So yes, if you understand if you were able to work with everybody through that fake exam review, the goal is that you should be ready for the final exam, definitely. And if you need extra practice, for example, exception, file handling, right? This is why I have the second exercise. So we are going to just take a look at it together. If I have time, I'm going to get you started, show you pretty much what is expected. We won't have time to finish it completely because we have like about 22 minutes left, but try it as an exercise if you need more practice, okay? Okay, yeah, that's exactly what this extra practice is about, okay? So I'm going to transition into that, but if you have more questions, keep sending them, okay? I'll interrupt and go back to the chat to address the question. That's the most important thing to do for this session. But since we are talking about, the review exercise, let me progressively transition into it. So it's a lot shorter. It's a lot easier and more straightforward than the fake exam that we all just went through, okay? It took us like almost 2 sessions to go through it, so you could expect that the second exercise is not going to take another 2 sessions because we don't have that much time before the final, okay? So this one is really in case you are not very comfortable with the last thing that we covered in the lecture, which was IO and exception, okay? Because that's the last thing that we covered, I expect a lot of students are going to be still feeling uncomfortable. So this is why the second exercise is on that specific focus. So let's take a look at what's at the menu for this exercise. So we are going to have a class called temperatures, plural, data store. And it's going to inherit from an array list of double. So it's kind of going to be the same thing that we did here, but instead of inheriting from an array list of a type that is an object, we just inherit from an array list of double. So it's a little bit simpler, okay, which makes the exercise shorter as well. So that class is going to serve us as a storage for a series of double or floating point values that represent temperatures. And we are going to be able to add temperatures to that class, and it's going to just add them to the array list. And eventually, we're going to be able to save those temperatures to disk, and we are going to be able to load them from the disk into the object, okay? So I can load an object, a text file with 10 temperatures, and those 10 temperatures are going to be added to my object, okay? So this is another thing that differs between this exercise and the previous. The previous one, the fake exam, we only wrote to disk. This one is going to get you through the practice of writing to the disk and reading from the disk. It's not that big of a deal. Writing generally is more complicated than reading, especially when we do things like append, like we did in the fake exam. But when we understand that, then reading should be okay. All right. So we want a constructor that takes a file name parameter. So it's going to be similar to what we did here, right, with the fake exam. We are going to store that in a private field, a private attribute named file name. And we are going to, in the constructor, create a file object and store that file object in an attribute named file. So a little bit different from what we did, with the fake exam. This time, instead of every time you want to write to the file, you create the file object, create the print writer, write and close. No, we're not going to do it the same way now. What we are going to do is when you create an object of class temperatures data store, you are going to record the file name, and you are going to already, right there, create the file object so that it's going to be ready in an attribute to use. So you don't have to create the file object right before you create the print writer. By the time you need a print writer, you're just going to pass the attribute to it as parameter, and you'll be all set, okay? And we want also to provide a method clear that removes all data from the array list. So I added that kind of at the last minute, just to make sure that you remember that in an array list, you have already a method clear. And that method clear, what it does is remove the data from inside the array list. So this is a, sorry, that last question here is almost a no-brainer, right? There's no work for you to do. because simply inheriting from array list is going to already provide you with that clear method. Okay, so let's keep going and let's look at what's next in this file, in this class temperatures data store. So the meat of it is going to be the save and load methods. Okay, so when I call my object.save, then all the temperatures that I've been adding to it until now are going to be saved to disk. When I call my name of my object.load, then it's going to look for a file on disk and load all of the temperatures from it inside the array list. Okay, so we do it both way like that. Of course, we are going to use that file object that we created in the constructor. Okay. The interesting part is both save and load are going to raise a checked exception, and more specifically, a temperatures data store exception. So that's our way to practice custom exception, which I really recommend you don't overlook for the final exam. Okay, so we are going to create a class temperatures data store exception. It's going to be a very straightforward custom exception. So that means that the code inside of it is going to do almost nothing. There's going to be a constructor. The constructor is going to take a string as parameter, and it's going to chain to the superclass constructor and pass that string to the superclass constructor, and that's it. Okay. The interesting part is once we have that class that is a custom exception, so inherits from the class exception, we are going to throw it around in certain situations. So here's a description of when we are going to throw around that class, okay? So when you try to save or load, if the file already exists or doesn't exist, then you throw that temperature data store exception, and you pass in the string an explanation of what's happening. For example, the file already exists, or the file doesn't exist, okay? If you don't have read or write permission when creating the scanner or print writer, so you get an IO exception, for example, then you are going to catch that IO exception, and you are going to throw instead a custom exception, which is a temperatures data store exception, with a message that says, for example, I got an IO exception, from my print writer, or I got an IO exception from my scanner. And then, if you receive a file not found exception from the scanner or print writer, again, you catch it and you rethrow a custom exception. So the idea is when we try to do our file IO for saving or loading, we may get some IO exceptions, but what we are going to do is we are going to handle them, and the only thing that's going to potentially come out of our method is going to be a temperatures data store exception. So it's like saying we convert our IO exception that we get from the method save and in the method save and load into a temperatures data store exception. So the main will only have to worry about catching a temperatures data store exception and display it on the screen, and that would be all. Okay, so that's pretty much it for the save and load. Now let's talk a little bit about the main. So we'll have a main method called COP2513 final exam. So it's going to be called review 2, something like that. I'm going to, by the way, upload a solution to this, since we don't have time to do it step by step in class, so that you'll be able to also look at the exercise, work on it, ask questions if you have problem, but also refer to the solution if you need to. Okay. So inside the main, just to test out our object, we are going to create an object of class temperature data store. We are going to add 3 temperatures inside. I don't mind, I don't care what temperature you use. Okay. We are going to call the save method so that it saves onto the disk in a file named temps for temperature.txt. You can name the file whatever you want. That's not a big deal either. Then we are going to add more temperatures. And then we are going to load from the previous file the temperature that we had originally. So if your temperatures are, I don't know, 10, 20, 30 degree originally, right? You save it to disk. So 10, 20, 30 degrees have been saved to disk. Then you add more temperature, let's say 40 degrees, okay? And then you reload. So at the end, what you have in your object in memory is 10, 20, 30, the original ones, 40, the one that you added after saving, and then 10, 20, 30 because you reloaded from the file that you just saved. Okay, and to make it easy to debug, you implement a toString method in your class and display with system.out.println the object, in between. So you add 3 temperatures, display the object on the screen. You save, I would say, yeah, display the object on the screen still to make sure, that you still have those 3 temperatures and nothing messed up. Then you add 1 more temperature, display the result. I should see 4 temperatures now. You reload from the file, display the result. I should see 6 temperatures, 7 temperatures now. Okay, that kind of stuff. And it tells you all of the class should be provided in the same file. Do as you prefer. Okay, the solution I'm going to give you provides all the classes in the same file, but this is just practice. So if you prefer to practice with separate files and for each separate class, please feel free to do so. Okay. All right, and that's it. So you will get the code for this, okay, so that you have also a solution. Uh, that's pretty much it for this review session. So we don't have time really to get started into that, but I'm going to open the floor for question. And if you want me to get started during that time, then I will be glad to do so. In the meantime, I'm going to stop the recording. So for those of you who are watching this, not live, but after the fact, good luck, everyone, for the exam. I hope that it goes through. We have been preparing all semester for that, so I really hope that you're not going to be surprised by the format, the scope, the difficulty, stuff like that. And we still have a few more days before the final, so please use that time to ask questions, come to the TA office hours. I have office hours also tonight, again at 7 p.m. to 8 p.m. So please use all the resources that we have to help prepare yourself for this final exam. And good luck for the final. Good luck for the finals in your other courses as well. And well, thank you for a great semester, everyone. Take care. All right, I'm going to stop the recording now.